Hi, today we're going to talk about transformations of different types of functions. This is going to be a part 1 of a part 2 video. In this video we are going to learn what the transformations are and how to identify them from given functions. And then we're going to go backwards and be given all the transformations and then be able to write the function based on those transformations. So the first thing we need to do is talk about what are all the transformations that can happen to a function. So I have a generic function listed here with a bunch of different letters in it. So let's go over what everything means. Y equals, you don't have to worry about the y equals, or it could say f of x equals. Just depends on whether it's an equation or a function. The first thing we have to talk about is there could be a positive sign or a negative sign at the very beginning of the equation. If there's a positive, it means nothing for transformations. You don't have to worry about it. But I typed a negative right here, so I'm going to kind of draw a little arrow way over here to the side. And if you see a negative at the very beginning out in front of everything, then that means reflection over the x-axis. Okay, the next thing that we have is the letter A. Letter A, one of two things can happen. If A is larger than 1, whoops, that's not a very good A. Let me erase that and try again. So if A is larger than 1, that's what we're going to call a vertical stretch by whatever the letter A is. And normally, what does that do to a picture whenever I say it's a vertical stretch? That means your picture becomes more narrow than the original one. Okay, so if A is not larger than 1, then that means A has to be between 0 and 1. Because remember, the negative sign in front already means a reflection. So don't keep the negative sign with the A. Just look at the number A. Don't worry about the negative sign. So if it's between 0 and 1, then that will be a vertical shrink. By A. And what does that do to a picture? Well, that makes your graph become wider than the original. Now, the letter F, that just stands for the type of function. So it means nothing in the transformation. Okay, so do not worry about the letter F. It just stands for the function type. Then I have some stuff inside the parentheses. Now, the parentheses could be an absolute value, it could be a square root, a cube root, or it could just be a parentheses. It just depends on the type of function. But I notice here that I have a negative inside. So you notice this negative is inside the function, not outside the function, like our first one. So if you run across this, then that will be a reflection over the y-axis. Okay. The next thing we have is the letter B, and just kind of like when we talked about A, ignore the negative sign. Don't say it's a negative B, just look at B only. And B, if B is larger than 1, well, this is going to end up being opposite of what the vertical stuff is. So on the vertical, if A was larger than 1, it was a stretch. But since this is B, this is going to be horizontal, and this would be a horizontal shrink. And then if this is backwards, then instead of just saying the letter B, you would say by putting 1 over B. And then what does this do to the picture? This actually makes the picture become more wide. So you'll notice that this is completely backwards from what we wrote down for the letter A. So you have to remember all horizontal stuff is backwards. So the next thing we have is, well, what if B is in between 0 and 1? Then that's going to be a horizontal stretch by just the letter B. And then what does this do to the picture? It becomes your picture more narrow. Okay, moving on. The next thing we have is the parentheses here. We have x minus h. Okay. If you see x minus h, it could be x plus h, so it just depends. But if it's x minus h, then that means you're going to go to the opposite because it's inside. So you're going to go opposite and you're going to go to the right. Because most people look at it as a negative h and they think you go to the left. But you have to remember, if it's inside the parentheses, it is backwards of what it looks like. And if the parentheses was x plus h, then you would think the opposite, so that would be go to the left h. All right, the last thing we have to chat about is this plus k at the end. Okay, this k is not in the parentheses, so if it is a positive k, let me write the plus a little bit better here. If it is a positive k, it'll go exactly how it looks. So you would say it goes up by k. If it's a negative k, then it goes down by k. So remember, things outside the parentheses are exactly how they look, but things that are inside the parentheses or inside the function are always backwards. Now, these rules you need to eventually work on memorizing because you'll need to have them down for whenever we take the quiz or the test. But for today, we're just learning them, so make sure you refer back up to the top whenever we're trying to answer these questions. So our first example here, your job is to look at the given function, and then you need to look and decide what happens. Is there a reflection? Is there a vertical stretch or shrink? A horizontal stretch or shrink? Did I go left? Did I go right? Did I go up? Did I go down? Okay, so under example number 1, I want you to understand the function type. So when I talk about what type of function this is, I'm going to highlight it here in purple. So I have this parentheses and then this power of 2. That is telling me that this is a quadratic because it's a power of 2. That means nothing for the transformations. So please do not use the power of 2 and try to say it's anything. Okay, that's just the type of function. So what we're really looking at is we're looking at this y, or y equals, and then after that we have this lovely little negative. And you should notice that this negative is outside of the parentheses. It's outside at the beginning. If you have a negative that's outside at the beginning, then that will look like this one up at the top where we have this negative before the letter A. So you would say, oh, well, this is a reflection, which I'm going to abbreviate now, REF, on the x-axis. Okay, the next thing I notice is I have this 1/3 that's in front of x. And you should notice that the 1/3 is inside the parentheses. So that looks like the letter B, because you'll notice here the letter B is inside of a parentheses. So currently my B is 1/3. 1/3 is between 0 and 1. So that would be a horizontal stretch. So I'm going to abbreviate horizontal stretch. And then you notice it says by the letter B. And b is going to be the bottom number of your fraction. Okay, so it's always like flipping the fraction over. And that's it, because the power of 2 means nothing. Okay, let's go to the next one. On the next one, the type of function, if you'll notice here, we have these lovely little bars that I'm highlighting in purple. And if you see those bars, that is what we call a absolute value. Okay, so inside the bars, I have this x minus 4. X minus 4, that looks like up here where I have x minus h inside the parentheses. So we talked about that being the opposite direction as it looks, so don't say left. Instead, you want to say, oh, this means go to the right 4. And then I have this plus 5 at the end. Anything at the very end is your letter K. And remember, K is exactly how it looks. So if I have a plus K, then that means I'm going to go up K, which in our case would be up 5. So those are my 2 answers. Now, will they all only have 2 answers? No. Sometimes they'll have 2 answers, 3 answers, or 4 answers, or etc. Okay? Just because the first 2 only had 2, I didn't want you to think that was always the case. So letter C, once again, type of function. I notice that I have a parentheses and a power of 2, so this is a quadratic. So the first thing I have is this 4 that's out in front. Anything that's outside of the function is going to be vertical. And this is larger than 1, so you would say vertical, which I'm going to abbreviate, stretch by exactly what it is, which is 4. Then you're going to notice that we have this negative that's on the inside of the function because it's inside the parentheses. And if you have a negative that is inside the parentheses or inside the function, that is reflection on the y-axis. And the last thing I have here is this minus 3. Anything at the end is up or down, and up or down is exactly how it looks, so I would say down 3. So this one had 3 answers. Okay, next one. Type of function. Hopefully everybody's like looking at this and saying, oh, this is a square root. Okay, the 1/2 is outside. So remember, anything outside is vertical. So vertical, I would look at this one and I would say, oh, this is going to be a between 0 and 1 because it's 1/2. So that would make it a vertical shrink by 1/2. Then inside, I have the number 4, and that would be what was in the letter B spot because it's inside the function. And 4 is larger than 1, so then that would put me at a horizontal shrink. And then remember, horizontal stuff is always backwards, so don't say by 4. Write the 4. What we mean by backwards is make it a fraction, so 1/4. Then the next thing I have is this x plus 1. X plus 1 is right or left movement, and right or left is always opposite. So in this case, you would say left 1. And then finally, the last thing is this minus 1. Minus 1 is up or down, and up or down is exactly how it looks, so I would say down 1. Okay, now we're still going to describe the transformations, but in example number 2, instead of me giving you an equation or a function, I'm going to give you pictures. So if I look at the first one, it says we want to go from F to H. And to help us go from F to H, you're going to notice that they were kind enough to put in the graphed dashed G. So technically we're going to go F to G, and then we're going to go G to H. Okay, for F to G, to me it looks like it's the same shape size. So I don't see any kind of vertical or horizontal stretch or shrink because I didn't make the picture become more wide or more narrow. But to get to F to G, I can pick a point. And then I can say I'm going to move that point to the left 2 spots. And that will make my F set on top of my G. So now what I have to do is I have to figure out how do I make my G become my H. And to me it looks like if I just take G and I flip it over, then it should match H. So what do I have to flip it over? Well, I would have to flip it over the x-axis. And anytime you're flipping something over the x-axis, you're basically saying it is a reflection of the x-axis. Okay, the next one, we're going from A to B. So we're going from the blue one to the red one. Okay, so on the blue one, I'm going to pick this dot right here. And how do I move that dot to the same location on the B? So here I would be like, well, I need to move it to the right 5. And then I need to move it up 2. So I went to the right 5 and I went up 2, and that would put me the dot in the same location. Okay, now I do notice that the shape has changed. Okay, if you look at the letter B, how does B compare to A? So did B become more narrow or did B become wider? And hopefully you're all saying, oh, B became more narrow. So if you look up above at the top, we said there were 2 ways that your graph could become more narrow. So I don't care which one you could choose. You could say either it is a vertical shrink. I'm sorry, vertical stretch. My bad, I cannot write today. Vertical stretch. Or the other one you could say is a horizontal shrink. I don't care which one of these you write, but you need to have one of them because they both make the picture become more narrow. All right, flip it over to the back. On the back. This time we're going to go backwards. I tell you what type of function you're going to write the equation for, and then I give you all the transformations. Okay, so I tell you we're going to start with y equals the absolute value of x, and then here's your transformations. We have a reflection over the y-axis. So if we look up above, anytime you have a reflection, it's going to be a negative sign. You just have to decide, does it go outside the function or inside the function? And if it's a reflection on the y, that means it would be a negative inside the function. Okay, horizontal, stretch by 2. Anything horizontal goes on the inside, and horizontal stuff is backwards, so you can't use the number 2. You would have to flip that, and so you would use 1/2, and you're going to put it inside in front of x. So it goes inside in front of x. Okay, right 3. Left or right is going to be written as either x plus or x minus. And remember, left or right is always backwards. So you would write this as x minus 3. And then the last one we have is up 6. Whoops. Let's switch colors. Up 6. Let me erase that and switch colors. So up 6 is at the very end, and at the very end it's always what it looks like. So you would have a plus 6 on the outside at the end. Okay, so let's start writing our answer. I'm going to go y equals. I don't have anything on the outside of my function at the beginning. So I'm just going to put absolute value. So there's my bar for absolute value. I have a negative inside. So here's my negative inside. Then I have to have a 1/2 in front of the letter x. So here's my 1/2. And then x is attached with your left or right movement. So then I would include my parentheses x minus 3. And then into my absolute value. And then at the very outside of it, at the end, I would put a plus 6. And there's my answer. Okay, let's try a couple more. This one we're going to do a quadratic because it says x squared. I don't care if you use f of x or if you use the letter y. That's up to you. But if it's a quadratic, you're going to have a parentheses with a power of 2. So, reflection over the x. Reflection means a negative, and then you have to look at the x-axis, and to be over the x-axis, that means the negative has to be on the outside at the very beginning before your function. And the next piece is a vertical. Okay, a vertical stretch or shrink is on the outside, and you'll use it exactly how it looks. So you're going to use the 1/3, and the 1/3 is going to go on the outside of the function at the beginning. Then we have this shift left. Left or right is inside, and remember it's backwards, so you're going to write that as x plus 8. And then the last thing we have is up or down. Up or down is at the end, and it's exactly how it looks. So you're going to put minus 10 at the end. So here we go. F of x equals, I have a negative on the outside, so boom. I have a 1/3 on the outside. That's next. Then I'm going to have my left or right movement, so parentheses, x plus 8, close my parentheses. Then I'm going to put the power of 2 just for my type of function. And then I have this minus 10 on the outside at the end. Done. Okay, last one. This one, we're just doing a regular old y equals x. So this one can just have a parentheses, no power of 2 with it. It's not a quadratic, so just a normal parentheses. Horizontal shrink. Well, remember, horizontal stuff is backwards, so you can't use 1/4. You're going to actually use the 4. And if it's horizontal, it has to be inside the parentheses. And then we have this up 5, up or down is at the end, and it's exactly how it looks. So you're going to have plus 5 at the end. So away we go. Y equals, I don't have anything on the outside, so I'm just going to go ahead and start my parentheses. I'm going to have a 4 inside. Stretch or shrink is always in front of the x. I don't have any left or right movement, so I'm just going to close my parentheses, and then I have plus 5 at the end. Boom. Now, some people will ask me, well, since this one doesn't have a power of 2, it's not a quadratic, it's just linear, do I have to have the parentheses? And since we don't have anything written out in front at the very beginning, then you don't technically have to have the parentheses. But I always use the parentheses. It just makes me feel better. So that's it for the first day.